the code in its final format, and that way you can focus on the ideas that focus on the ideas that we're talking about today. Okay, so I'm going to go ahead and introduce the bunny races here. So we go in and we'll talk about the basics of these so-called races. So I've got a little picture here. So I want you to imagine that we've got a little bunny at 0. He's microscopic, of course, and he is wanting to finish this race that he'll know that he's done when he crosses 1. So he's constrained to take little hops in an interval from 0 inclusive to 1 exclusive. And we're going to just ask this dumb question, as if we care on a Saturday. How many hops on average will it take that bunny to finish the race? And we're going to use Python coding to help us answer this question. And I'm hoping, especially those of you that are math teachers, might be really surprised at the result that we get in the end. But I'm going to leave that as a teaser. Won't give it away just now what's going to happen. So that's the idea. Now, what I like to do with my students is whenever I'm doing my work, I like to often show them what they can kind of expect. So I will have written this code ahead of time, and often we'll give some kind of a preview of, hey, this is what you should expect when we're done. And so you can see I've got 2 versions here. I've got monitored bunny races and summarized bunny races. And so let's talk about the monitored first. So if we do our software right with the coding we're about to do, I've got a nice little heading, bunny races. How many bunnies do you want to race? It asks, and it gives you a chance to respond. And then hopefully you give some meaningful number. And then it's going to ask you, hey, do you want to see these runs? Because, you know, if we've only got 5 bunnies, yeah, I might like to see how many, which bunny did which as far as finishing the race. But if I've got 5,000 like I have over here in the summarized, I don't necessarily want to see all those individual things, because I will be summarizing my statistics when the code is all done anyway. So that's the monitor. Now you'll see that I'm censoring the yellow here because I don't want to give away the punchline here. No one wants any spoilers just yet on what's going to happen if we race lots of bunnies at once. And so I'll leave that to your imagination. But let's move on then and actually start trying to do some coding. So I have a coding framework that I usually establish for my students. And so in my Python classes, normally if I write a program from scratch with them, I will give them a stub or a framework. I've got some heading comments here with the exercise and the coder and the date. And then I have little regions of comments here for imports, global variables, functions, what I call the main event, which is kind of driving the engine of the code, and then sample output. And by doing this, I'm giving them little cubbies to fill things in. And when I go and grade their work, I find that that helps me look for things in the proper place. So that's kind of our framework for today. So then if you look at the starter code and or just look at this screen, in this particular application, and maybe even in the assignment when I gave this to the students, I will often provide what I call the main event. The main event is kind of the driver or the engine that's going to make this thing do its job. And oftentimes the students, their job is to supply the stuff that's mentioned in the main event. So you see, I've got a little heading, bunny races, and I've highlighted here that this is, you know, kind of a dangerous thing. I've got a possible infinite loop here, while true, colon, and then I like to, don't laugh at me, but I like to have markers that show the end of loops. I know that's pretty juvenile, but it helps me see the end of things, and I like my students to do that. So I've got this while true thing and in my while loop. And as you know, if I've got an infinite loop possibility, I've got to have a way of breaking. So I do see a break. That makes me feel a little bit happier that things are not going to go nuts. And so I've got this infinite loop where I'm going to keep asking, you want to race some bunnies? You want to race some bunnies? And so then if they say, yes, I want 5, notice I am integerizing the input, because you know in Python, anything from the keyboard goes in a string. You've got to make it into an integer. And that's been covered maybe in previous lessons in the CodeHS ecosystem for Python 3. But anyway, I've got an n, and notice it makes me feel secure. If n is less or equal to 0, I'm going to break. I'm going to get out of Dodge. And notice I will come outside of the loop. And I like to have, I think this is kind of a good thing. I like to put a little message to be polite, saying thanks for using our app, and also make sure there's nothing running in the background. So thanks for using our app. So I have a way of getting out of Dodge. Now, let's suppose I say I want to run 5 bunnies. Well, then I'm asking for one more thing. Remember, the monitored versus um, the summarized version of our code. So I have a Boolean variable that I would like to create. I've got a string here. I'm asking, would you want to show each run, yes or no? And so there's show each run. That going to presumably are yes or no. Now, I like to teach my students this. I like to say, hey, pretend that complete idiots are going to be using your program, or someone's kind of being mean. They're wanting to try to see if they can crash your program. Well, or just suppose they didn't pay attention. So they type, I said type a yes or a no, but they or a Y or an N, and they say YES or yeah, YEAH. Well, I'm going to be thoughtful about this and think, well, let's make it into lowercase and then grab the first character of it. So this is an aspect of string manipulation, which we've already covered at this point in our course. And I'm hoping that kids feel pretty good about that. So now I've sanitized the input for show each run. And now I feel pretty good that this selection logic is going to work. Hey, if show each run is yes, we're going to say show runs, the Boolean variable is true, else show runs is false. So, and that's going to be showing up here in my little loop for running bunnies in a moment. But then I'm creating what Python calls a list. I often will mess up and call it an array because I like to teach Java too. But anyway, I've created an empty list called hops, which is going to record all the hops for each of my individual bunnies. Then you see I've got a for loop, and lo and behold, I've marked the beginning and end of it. Okay, again, don't laugh at me. I just kind of need that kind of thing. And I like to point out to my students that this is a nested for loop. It's a while within a for within a while. So in this case, I'm using the range idea of creating a variable. I've got B for bunny. So for every bunny in range, starting with bunny number 1 and going up to n+1. Now you might remember that if somebody typed a 5, the second parameter in the range function says, hey, go up to, but not including that. So that's why the +1 is there. And every time we up B, we're going to go up by 1. And this is a kind of a classic for construction. Notice my indentation for my loop. I'm going to say num hops is race a bunny. So if you scanning this main event, then, which I've provided, I tell the students, say this fully functionally works if you just follow my lead. So students would maybe recognize, hey, race a bunny is a function I'm going to have to provide. It's going to be a return type function for num hops. And then if show runs, we've enabled that. We're going to stringize my bunny number, and we're going to stringize my hops number. We're going to see those bunny hops going along if it's not too many of them. But you got to make that choice, didn't you? And then we've got to remember that we've got to add to our hops list. So there's hops.append num hops. And so num hops will be appended to hops. That's how you add. This is a function. We'd call it maybe a method because it's in the list ecosystem. We're going to append that hops. And so this is going to happen for however many bunnies. And then once this is done, we're going to get our statistical analysis of the hops. And then the fun starts all over again. We can race another set of bunnies. So our job then, having studied the main event and kind of refreshed our memory of what's going on, we're going to go on and look at some racing secrets here. Now, if you're new to Python or new to programming in general, I usually will kind of summarize for the students, hey, this is the stuff that we need. So because these bunnies are hopping randomly, we're going to have to import the random module. And so there was a place for imports in my code. We'll need that. And then the only function we'll be using from the random ecosystem or the random module is the random function. And doesn't that look like a bunch of double talk? Random.random. I know that's random, all right, but this is going to be the thing that generates my number between 0 inclusive and 1 exclusive. And notice, being the former math teacher that I am, please forgive me, this little sucker right there is interval notation that most math teachers like to utilize with their students, and I use it with my students too. So I'm going to use random.random for my random stuff. Now, function stuff, I'm a big proponent of writing functions to do stuff. And so we already alluded in the main event that we have race a bunny and we have stats. Now, the differences between the two functions is that one does not take parameters and one does. And I often will make a difference between those two things. One is a return. The return function race a bunny, it does going to return the number of hops for one bunny. And then stats is going to be just printing stuff out. So it's not return, it's just doing its job. Now, here's something I learned from my students, and this is something that's embarrassing and also kind of thrilling, is that I didn't know about this little keyword called pass. So if you try to create some shell code for your students that they plug in and you just provide comments in the function, CodeHS or Python doesn't like that. It gripes and is griping about indentation errors because it's like, hey, why would you create a function and not have anything in there? So you can create this little pass keyword that basically says, hey, chill, we're going to put some code here in a minute. Don't worry about it if it doesn't do anything. And I owe one of my students for learning that or for teaching me that. The other thing in our racing secrets is statistical stuff. And so let's suppose I've got a list, LST, with 10, I believe, hops for bunnies. What I notice is that there are some things that are built into Python which make things very nice. There's a length function that lets me get the number of elements, the len of my list. There's a sum, min, and max function that will say, you give me a list, or you give me an array, or you give me that entity that holds my stuff, and then I will find the sum for it. And I'm going to be using some variables called asum, amin, and amax, as we shall see in a moment. And then also the other thing is the frequency array or frequency list. There's a really cool way of generating some empty pockets for it. I can say, hey, let's create a list that starts with 0 because we're not going to have any bunnies at first, and let's multiply by a max, and that will give us if the largest number of bunnies that or largest number of hops that bunnies ever took was 5, I'll have 5 zeros. So 1 0 can count the number of 1 hops, and then 2 hops and 3 hops, etc. And so that's going to house our hops. Now, I will often with my students encourage them to find built-in code. Other times I'll say, hey, let's do it from scratch. Let's make kind of like homemade ice cream kind of max feature. We don't want to buy store-bought max. We want to make homemade ice cream. So let's make that on our own, and you could use that if you wanted to. So at any rate, that's what I'm talking about. Brute force is sometimes really instructive to help them learn or remember ideas of loops and accumulators and things of that nature. But anyway, moving along, I'm going to go to my next slide here. And so this is the final code for bunny race. And we are going to actually type it out in a moment, but let me give you kind of the high-end view of it. So notice I've got a define race a bunny function, no parameters, colon, all the stuff is included, including the return. Notice, again, you're going to laugh at me, I put a comment marking the end of my function. That makes me feel comfortable. I think it's the Java programmer in me. I just still can't get over the fact that there's no open and close curly braces. But anyway, so notice I've got B for bunny. I like to have meaningful variable names when possible. Hops in this case is my accumulator. And oh, lo and behold, a while loop. While bunny value or bunny location is less than 1, we're going to up our hops accumulator. And then also, this is the real thing that makes it work, or we'll have a dreaded infinite loop. We're going to use our random.random thing. Remember, random.random gives us a number in 0 to 1, inclusive of 0, exclusive of 1. And that's going to be adding to my B. So B is the little bunny is going to go hop, hop, hop down the number line. Eventually, it will get larger than 1, which will end my loop. Oh, look at that little indicator of marking the end of the loop. That looks so nice, doesn't it? And so I've got that, and then I return hops, and the bunny is done. Now, you might sit there thinking, oh, I wanted to code it. Well, we're going to have a chance to do it in a moment, but I thought it might be helpful for you to see the big picture since we've only got 45 minutes, and you don't know me well yet, but I'm pretty long-winded. But so anyway, that's our race a bunny. Now, when we go and look at the other component of our stats function, once more, now look at the difference between this one. It's def stats, but this time it's got a parameter, LST, and we'll talk more about that choice of variable name in a moment when we start coding. And notice I've got a little heading saying we're doing our stats. We're populating all of our stats variables. So I'm using the length function to get in. I'm using the sum function to get my sum. And I don't believe there was a data type or a built-in for an average. So I had to compute that myself. I had to take the sum and divide by n. Now you might be, I just can't resist showing this to you. I've got this little comment there, DWR, and you know what? If we had time, I'd give bonus prizes for those that could guess what that means. But I'm going to show my age here, but I've got actually a little hyperlink. I've just got to show you this. Whenever you do division, I tell the students, when you see division, you've got to start freaking out, because it might be that you have the wrong data type there. You might truncate your answers. You might want decimal values in your answers. And if you're using integers, they're going to truncate, and that's not happy. So what is this DWR thing? And it's got a question here about data type. I asked them to think about that every time we do division. So what is that all about? So DWR is my way of alerting to the students of danger. And so when in the 60s, there was this really corny show called Lost in Space, and the robot was always telling his friend, "Danger, Will Robinson." And incidentally, if you haven't seen the Netflix remake of Lost in Space, that robot says "Danger, Will Robinson" too. So you can use the updated version if you like. But so anyway, we'll talk about this in a moment, some "Danger, Will Robinson" moments in this code. But going back to where we were, oops, I didn't want to go there. Yeah, so there's our stats function. Danger, Will Robinson, worry about data type when you divide, especially. I print out my average, my minimum. Now, we probably won't do this in a moment when we actually code for the lack of time that we've got, but I was talking earlier about brute force versus built-ins. I tell my students, hey, look, when you're doing something, always look to see if there's a built-in first and see if you want to use it. And then if so, great, you might have saved yourself a lot of time and energy. Other times I'll say, yeah, I know there's a built-in that will find the maximum, but I want you to do it by brute force. I mean, it's nice to be able to make homemade ice cream, not just by Bluebell, right? So anyway, in the yellow here is the way of finding the max by brute force. And I think there's actually a CodeHS lesson on this in the Python 3 ecosystem. But the idea there is I look at my list and look at the 0th element there, and I assume that that's my maximum. Then I'm going to iterate through my list. That's a fancy word, isn't it? Iterate for V for value in your list. If your value is larger than a max, ooh, my gosh, that's embarrassing. I do not have that indented, and I should. It's a if statement, and it needs an indentation. Actually, I could lie and tell you I put that there to see if anybody would catch it, but you know I was lying about it. But anyway, that should be indented. That's embarrassing. And then we end our for loop. We'll make sure we don't make that mistake when we actually code it. I print out my maximum, and then we're nearly done with this actually, and then we'll start coding. Here's our stats function continued stuff. So here's the frequency analysis. And once more, I create an empty list called freak. I'm going to iterate through that list. And then notice for every value in the list, I'm going to say freak v minus 1 plus equal 1. And I'm going to explain that actually when we get to the code. So we're going to come in and actually go to CodeHS now. So I'm going to break this, and maybe you had a chance to load up the starter code or the final code, but here I am. I'm going to go to my working code. And so here's, let's see here. So here's mine, and I'm going to pull it up here. So there it goes. And so if you want to pull up your starter code, so this is the little splash screen explaining the bunny races, and away we go. So now when I get this stuff, now keep in mind, we do have the starter code and the finished code. So if you get nervous that you're not going to get done, it's all there for you anyway. But notice I've got some header comments. There's my little scaffolding. There's the main event. Whenever I do this from start, I will often actually just run it and see what I get. So, oh, there's my starter code or my main event. How many bunnies do you want to race? 5. And show each run, yes, because it's a small number. And oh my gosh, look, I've got a dreaded error, name error, race a bunny. And it's not surprising because I don't have that function created. So in my functions area, I go def race a bunny. parentheses, colon, return. Now, if I was actually wanting to do that pass thing to get this to chill for a moment, I could go pass, and I'm going to go ahead and do the other one for the other function, def stats lst colon pass. And this is the beauty of that little pass thing. When I save and then I run, I can demonstrate that the shell code works. So I'm going to, how many bunnies to race? 5. Come on. Okay, it's thinking. So it should be asking me, show each run, and it got a little, looks a little laggy here. Okay, sometimes that makes me nervous. I'll restop.
Kent, I think Zoom just makes things a little slow.
A little more laggy. Okay, so I'm going to run it again. Let's just see. So how many bunnies to race? 5, return. Okay, show each run. That makes me feel better now, Lucas. Thank you. And so show each run, yes, because it's a limited number. And notice my driver code is working. That's a reference to some Java parlance that I use. But notice bunny number 1, nothing. Bunny number 2, nothing. How many bunnies to race? Well, can I make this end? 0. Yes, I can make it end. So that's working great. It didn't crash. Now that I've got the pass thing working, I can actually come in and type in my code. But you know what I think I'm going to do? Well, actually, we'll do it with race a bunny. So here's race a bunny. So we said create a variable b equals 0. And then we had hops equals 0. And then while b is less than 1, colon, return. And notice it auto indented. And now hops is my accumulator. So hops plus equal 1, and then b plus equal random dot random, the little thing we were talking about. Now I'm going to go ahead and mark that's the end of my loop. I just can't hardly resist doing that. And then hashtag end function. Now, if you're watching carefully, you're going to say, no, don't pull that trigger, don't run, it's going to fail. Because when I come in here and I do this and I run it, how many bunnies to race? 5. Show each run, yes. Oh, look, it doesn't know about the random module yet because I didn't tell it to worry about that. So, okay, so let's go up to imports. Notice how nice, I've got a little section already for it. So import random will bring in that module. And so now when I save, stop, run, how many bunnies? 5. Show each run, yes. Oh, what's wrong? What's wrong? I have the random module. It didn't crash. It didn't do anything. Oh, but wait. Race a bunny is a return function. I forgot the return statement. And you know what? That's one reason I like Java better than Python. Python's got a lot of nice things, but Java would never let me talk about a return function without a return statement. So return, I'm sorry, Python, return hops. And so now save, stop, run. How many bunnies to race? Let's go 5. Show each run, yes. Oh, it's great. I'm in heaven. I'm getting bunnies that are being raced, but I don't have the stats. So now, although I had a pass for my stats, now it's time to do some work with that. Now, incidentally, once you're done with pass, you can get rid of it. It doesn't hurt anything if it still stays there. So in stats, I'm going to come in now. Stats, I did something here that you might not have had to do, but I did it. Under global variables, I might want all the children in the sandbox to know about some variables that are statistical in nature. So up here, I'm going to say n equals 0, and that's the number of bunnies. I like to put a comment saying what it is. And then a sum equal 0.0. Now I'm remembering the idea of data type. So I'm saying let's use a float here to avoid any division issues. Also here, avoid sum, since that's a function name. So I'm calling it a sum is 0, and average is 0.0, a min equals 0. Now that's going to be integer, so I don't have to do the 0.0 thing. A underscore max is 0 also. Now, notice that I didn't use min and max. Again, you don't want to use variable names that are the same as function names. That can cause great trouble. So I'm going to save. And now that I've got those little variables created, let's go down to stats. And so I got to make sure I indent. So I'm going to say print dash, 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 summary statistics. And then I'm just going to start creating these variables. And we already kind of talked about it. N shall be the length of LST. Now, again, I'm using LST, not L, because L can be confused with a 1, not LIST, because that's a variable name. I mean, that's a function name. So but I want to have something that's kind of phonetic and kind of self-documents, which is a good idea. So I'm going to go ahead. I'm going to create all my variables and print them. How about that? So a sum will be the sum of list. I just love that. I didn't have to produce my own code. And then a min equal min LST. A max equal max LST. And if we had time, I'd actually do that from scratch, but it's a Saturday. Y'all want to get out of here early, I bet. So anyway, I've got a sum, a min, a max. And now I haven't printed them out yet. Oh, we probably need an average equal. Now that's again a sum divided by n, and I cannot resist. Danger, Will Robinson. Okay, of division. Okay, and data type. Making a note to myself that that could cause a problem. We need to come in. The whole purpose of stats living is to print the stuff out. So I could go print and n equal. Now, most of you know in Python, it's annoying. You have to put a little stringy thing in there to make sure that it knows how to get strings and numbers to play nice. It's a hassle, isn't it? And I'm going to be lazy, and I'm going to copy that, Control C, and tab over Control V, and then just say my sum is a sum. And actually, I probably should run this to make sure I'm not copy pasting garbage. So let's mark this as the end of my function, and be nice if I could spell it right. And let's save, stop, run. Now, see, I'm copy pasting, but if I copy paste a bunch of junk, then that's not good. So I'm going to go 5 and show each run yes. And oh my gosh, look, summary statistics, n is 5, sum is 18. Now let's double check, okay? 4 and 2 is 6, plus 5 is 11, plus 3 is 14, plus 4 is 18. It's working well. So all we got to do, it looked like my strategy of copy pasting my comments was good. So I'm going to go Control C and Control V, and I want to print out my min is a min, and my max is a max. And last but not least, the really important one is my average. So average equal an average. And so that was the whole purpose of this. Now we also, I got excited here. Let's go ahead. We don't have the stats thing yet, but let's see if this works. So how many bunnies to race? 5. Shorts run yes. And we could go in and get our calculator and check to make sure that everything's all right, but I think it probably is. Now, let's go ahead and do our frequency stuff. So hashtag frequencies, kind of a change of pace. So I'm putting a comment there to let me know. And you remember our little trick of saying freq equals square brace 0 times a min. Now, if you had a max, I mean, if you had said max here, you'd be multiplying a list by a function name, and there's no telling what that would do. It would cause disturbance in the force, no doubt. But So now I've got my freak, and I'm just going to say for V in free in LST, I want to go freak square brace V minus 1. We'll talk about that in a second. Plus equal. Now, I've been using the plus equal thing pretty freely. Some students might, if they're nuts, want to type it out to remind themselves that you've got the left-hand side being assigned the right-hand side. So I could do this. You can see what a hassle this is to type all that out. But I could have used the plus equal thing too, and I'll mix it up a little bit at times. And so now let's see if that's going to work. I'm going to go print freak. I could make it a pretty print thing, but I'm just going to print it out since we're in a hurry, and save, stop and run. And let's see how many bunnies to race. 5, because we're still just checking to make sure our code's working well. So now look here. In this case, the maximum was 3. There were 3 entries. There are no 1s. Now, the reason that 0, this is zero-based indexing, of course, and that's room 0. But the way I rigged it, if I'd had a 1 minus 1 is 0. 1s would have gone in that first slot. If I have a 2, 2 minus 1 is 1, and that would be in room number 1, which is the second slot. And notice there's 4 2s. So this is working like a charm. And so how many bunnies to race? If I really got wild and crazy, I could start saying 5,000. How many shows run? Now, this is the case where, no, I don't want to see all of them. It'll upset the console. And now this is where we're going to let the cat out of the bag, or the bunny out of the box, or whatever, because some of you that have math background are going to be shocked, I think. When I come here and I look with 5,000 bunnies with some statistics, a maximum of 9. Wow, that was a special needs bunny. But notice my average, 2.7172. Now you might think, so what? And I'm going to end the race here. But let's talk about the implications of this. We've got a couple of minutes left, I think. But if I go back to my PowerPoint for just a second, we were talking about monitored and summarized data. Well, now I've uncensored this. And you saw my eyes get buggy when I saw that 2.7 something or other, and you think, what's the matter with him? Well, here's the bunny races summarized. It's no longer censored. And I ran this for 5,000 and I got a 2.7154. Got a little lightning bolt there, must be important. And here I'm salivating all over it because I recognize that number. And if you're a math teacher, maybe you do too. When I come over here, now I didn't add this to the code. I did it this morning in anticipation. I just couldn't stand the suspense. You can actually find that number is in the import math library. It's math.e. Now, some of you may recognize that E is one of those numbers in the universe, like pi, that's pops up in all the most unusual places, and you can get it from math, import math. I created a variable called VE equal math.e. I could have gotten pi that way too. And if you look at my little output here, you'll notice I summarized and found that my value V for this run of 10,001 bunnies gave something with a percentage error of 0.02%. Now, this should just drive you nuts. This is going to ruin your Saturday. Okay, how can a random process generate a universal constant in the universe? That's very upsetting, very disturbing. I guess I could say, see your local math teacher for that. But I just think that's amazing. And I like to have things like this that kind of surprise my students if they've had a math background. This is, I think, kind of shocking. And it's kind of in my kind of way I try to address my students with, I know this is true for me, maybe it's true for you, is that the idea that what we learn with pleasure, we never forget. And so I have these little zany little things like bunnies and generating E, because I think it's computer science can be a little dry at times. And being with a math background I've got, I like to kind of dress it up a little bit and hopefully make it kind of fun and kind of engaging. And I see we got a couple of minutes left, but Thank you very much. This is my first time to get to present at CodeHS, and it makes me so happy to get to do it. And I've got my name here. This is my email if you want to reach out with any questions. I also have a site that you could look at if you like. I call it TNT, which is short for technovicetools.com. And here's where I showcase a lot of the work that we do and or pre-introduce assignments that we're going to be doing in whatever languages that we do. But that's all I've got. And I think I've got 2 minutes left, which for me is very unusual. Usually I'm 20 minutes over, but Lucas and Rachel and the gang, do y'all have anything to add? Do you need to reel me in? Anything I need to,
And the
didn't look
fact
at the
that
chat, so.
the fact that you say you normally go 20 minutes over, I'm about 20, 25 minutes over myself normally. So the fact that our group here ended on time is just about as amazing as your presentation. This was
Almost as amazing as E generated by a bunch of random numbers, almost.
Yeah, I definitely understood what you were talking about there. Kent, this was fascinating. Lots of people were talking about this as their post AP offering as something to do after the exam
Oh,
with their
wonderful.
kids.
And it lends itself well to all the other languages. So I do this with my Java classes. You can just take it from one language and
So
split up and get it in other languages.
everyone, if you please check the attendance link. And then Kent, if you have this in Java, I think even just the starter, it would be amazing. You and I will talk after. I think we could
Okay.
send that out to everyone. That would be a great thing. A bunch of people were asking about that.
Okay.
But Ryan and Rachel, are there any kind of specific questions that we saw that we want to ask with our 60 or so seconds?
Yeah, there was just one question that sorry, Rachel, you're probably going to ask the same thing that I was going to say. But we did have one attendee that wanted to know how long you usually give your students to complete this lesson in particular.
That is such a great question. I will often, like if I were introducing this idea, I might give them this as a homework and say, you've got, maybe give them 24 hours. So I will make a student version and then a solution version in CodeHS. And so the student version, I keep it unlocked for maybe 24 hours and then I lock it down and then we show the solution. And then that way they can look at what they did versus what I did and then kind of compare and contrast because they may have had some other ways of doing it. Some kids don't like to use my starter code and they want to make their own. And I say, okay, that's great. Do it the way you want to, freestyle, and then we can talk about it. But normally it would be like an overnight homework assignment, especially if I've given them the driver code. Now, if I hadn't given them the main event, this might be a couple of days long because they've got to write the cycling of everything too.
And I can't thank you enough. The 30 plus people in attendance, thank you for coming to this session on Bunnies and Python 3. Kent, you are a fascinating teacher, and I really appreciate you presenting.